Okay, good morning again, everyone. This is the second lesson for the second day of the new school year. So, as I mentioned earlier, we will move fast, and so we're going to now go on to section 1.7, function notation. Our objective today is to write functions using function notation. We'll figure out what function notation is in a minute, and then we'll evaluate and graph those functions. Graphing is a very important part of Algebra 2. Algebra 2 is all about understanding functions, all the functions you will learn in Algebra 2, so graphing is very important. We have some vocabulary terms here of what do we mean by function notation, and then what's the dependent variable, and what's the independent variable. So a couple vocab terms there. Hopefully you'll understand everything at the end of the lesson. So let's look here. Some sets of ordered pairs like x and y can be described by using an equation. And you guys are familiar with some of the equations you saw in Algebra 1. So for example, like a linear equation, if you remember, y is equal to mx, the slope, times x plus b, the y-intercept. So for example, like y is equal to 2x plus 1. Okay, so for any x we get a y. So for example, if x is equal to 2, we get y is equal to 2 times 2 plus 1. So that would be 5. So x would equal 2 and y would be 5. So ordered pair would be 2 and 5. If x equals like -1, we would have y equals 2 times -1 plus 1. -2 plus 1 would give us -1. So my ordered pair, x would be -1, and then y would be -1. Okay? All right, and so rather than using what you learned in Algebra 1y, we'll use something else. Okay? We'll use function notation. So let's take a look at function notation. So here, function notation, we use what's called f of x. That does not mean f times x. So this is read f of x. F of x. F of x. And here we're saying f of x is equal to 5x plus 3. Well, in Algebra 1, we would have said y equals 5 times x plus 3. But it's the same thing, 5 times x plus 3. Now we'll just replace y with f of x. Okay? All right, so when x is equal to 1, or y is equal to 1, as we see here, when x is equal to 1, well, in Algebra 1, you would have said y is equal to 5 times 1 plus 3, and so y would equal 8. Okay, but now we'll just use function notation. Okay, so rather than using y, we'll say f of x, or f of 1. And the reason we do that, because now it's crystal clear that the function depends on x. Okay, the value of f of x, or y, depends on x. If you don't believe me, look back at what I did. When x was equal to 2, y was equal to 5. Okay, when x was equal to -1, y was equal to -1. So the function depends on x. It's not so clear. It's not so clear here. It's not so clear with this here, that y depends on x. It's crystal clear now here that y, or f of x, depends on x. All right? That's why we use function notation. So the function described by f of x is equal to 5x plus 3 is the same as the function described by y is equal to 5x plus 3. And both of these functions are the same set of ordered pairs, x and 5x plus 3. Okay? X and 5x plus 3. So that was y. Or it was equal to f of x. Okay, f of x was equal to 5x plus 3. The important thing is y and f of x, y equals f of x. Okay, so they're the same. Keep that in mind throughout the entire school year. Y and f of x, they're the same. They're twins, right? Okay, yeah. One twin may be called Ronald, and the other twin may be called Donald, okay? But they're the twin. They're twins, okay? They mean the same thing. So y and f of x means the same thing. So here, so I can say y is equal to 5x plus 3. Okay, so order pair x and y, or x and 5x plus 3. All right. Or I could say f of x equals 5x plus 3. Again, y and f of x, they're the same. Or x and f of x. Remember, f of x is y. Or f of x is 5x plus 3. So x and 5x plus 3. Okay, so it all means the same thing. Y equals 5x plus 3, or f of x equals 5x plus 3. It all means the same thing. But we'll use function notation. Most of the time in Algebra 2, we'll use f of x, or g of x, or h of x, whatever. It's all the same. So the graph of a function is a picture of the function's ordered pairs. So let's look at this. Oh, so I did mention this. F of x is not f times x, or f multiplied by x. F of x means the value of f at x. So f of 1 represents the value of f at x is equal to 1, or the value of y at x is equal to 1. Okay? 6 chocolate chip cookies or half a dozen of the same batch. It's all the same. It's all good. Okay? Y or f of x. So for each function, evaluate the function when x is equal to 0, or x is equal to 1/2, or x is equal to a negative 2. Well, my function, or my rule says here, we take the input value, x, we multiply it by 4, and then we add 8. So all we do is we substitute in x. When x is equal to 0, I'll just replace x with 0 in the rule. 8 plus 4 times 0 is 8. When x is equal to 1/2, I'll just replace x with 1/2. Well, 1/2 of 4 is 2, and 2 plus 8 is equal to 10. When x is equal to negative 2, when x is equal to negative 2, we just replace x with negative 2. 4 times negative 2 is negative 8, and negative 8 plus 8 is equal to 0. Okay? So, the input is x, the output is f of x. All right? The input is x, the output is f of x. And that gives me my ordered pair. So in this example here, my ordered pair would be 0 and 8, 1/2 and 10, and then negative 2 and 0. Ordered pair, x and f of x. All right. And then here, so let's look at this. Evaluate each function for the values when x is equal to 0, when x is equal to 1/2, and x is equal to negative 2. Here we don't have a rule like we had up above. There we had a rule, and the rule was you take x, multiply it by 4, and add 8. The rule, in a sense, has already been defined by us, or given to us by the graph. So all we have to do is take a look at the graph, go to the x value that they give us, and then look at what's the corresponding y value. So the x value they give us is here. So I have to go to the graph, and there's x is equal to 0. Then I go up to the graph, and right there, y is equal to 3. So the ordered pair would be 0, 3. Okay. And again, they give me the value for x is 1/2. I go to x is 1/2, and then I take a look at the y value. Well, the y value is 0. Okay. So the ordered pair would be 1/2, 0. And then x is equal to negative 2. I go to negative 2, and I go up to the graph, and I get 4. So my ordered pair is -2, 4. Right? The rule is a graph. We start at the x, and then we go up to the graph to find the y. Let's look at the next one. For each function, evaluate f of 0, 1/2, and -2. So again, the rule here is you take x, you square it, and then you subtract 4 times x. Or you take the input, square it, and then you subtract 4 times the input. So when x is equal to 0, we have to take 0 and square it, and then minus 4 times 0, and that gives us 0. When x is equal to 1/2, we have to take 1/2 squared, multiply that by -4. We take 1/2 and square it, and then we subtract -4 times 1/2. We take the input, x, we square it, and then we subtract 4 times 1/2. Okay, so 1/2 squared is 1/4. 1/2 squared means 1/2 times 1/2. When you multiply fractions, you multiply the numerator and denominator. 1 times 1 is 1, 2 times 2 is 4. Okay, so that gives us 1/4. Then we take -4, -4, and we take half of that. Well, that's equal to -4/2. Okay? But we have 1/4 minus 4/2. And you remember you can only add and subtract fractions if they have the same denominator. So we have to multiply that by 2 and that by 2. And now we have 1/4 minus 8/4. And that gives us -7/4. Okay, but the rule is you take x, so 1/2 squared is 1/4. And then -4 times 1/2 was -4/2. But then we have to have the same denominator. And so we have 1/4 minus 8/4 is -7/4. And then the last one here, what is it when x is equal to -2? So we have to take -2 and square that. So -2 times -2, that gives me 4. And then we have to take -4, -4 times -2. A negative times a negative is a positive, and 4 times 2 is 8, so we have a positive 8. And then we have 4 plus 8 is equal to 12. Okay. The next one. So we evaluate the function when x is 0, 1/2, and -2. The rule is you take x, multiply it by -2, and add 1. When x is 0, -2 times 0 is 0, plus 1 is 1. When x is 1/2, 1/2 of -2 is -1. 1/2 of -2 is -1, plus 1, and that gives me 0. And then when x is -2, -2 times -2, negative times a negative is a positive. 2 times 2 is 4. And then we add 1 and we get 5. Okay? Order pairs, 0, 1, 1/2, 0, and then -2, 5. We'll get into graphing those in a second here, but if I were to graph that, x and y, when x is 0, I get y is 1. Oops, let me erase that. When x is 0, when x is 0, I get y is 1. When x is 1/2, if this is 1, when x is 1/2, I get 0. And then when x is -2, when x is -2, I get 5. So 1, 2, 3, 4, 5. So, all right. And then we could, it's a function and we could draw our line, so like that. We'll be graphing the ordered pairs as well. In the function notation, f is the name of the function. The output f of x or y is called the dependent variable because f depends on x. Okay, the input x is called the independent variable. When a function is graphed, the independent variable is graphed on the horizontal axis always. Independent variable. And the dependent variable, your y, is always graphed on the vertical axis, always. So here, they give us a function d of t is equal to 65 times t, or distance is a function of time. Well, rather than using t, distance depends on time. Okay, if you're driving 50 miles per hour in 1 hour, you drive 50 miles, 50 times 1. In 2 hours, you drive 2 times 50, 100. So the distance depends on x. So rather than using y, we'll just use d of t. So d of t. That's my dependent variable. And then rather than using x, we could just use t. Okay, so that would be the preferred way. So rather than using y, we use d of t, and rather than using x, we use t. So as you can see, at time 0, okay, we've gone nowhere. In 1 hour, we've traveled 65 miles. Okay, so this, in 1 hour, I guess that represents 65 miles. In 2 hours, 65 times 2 is 130. So that would be about right there. Okay. Graphing functions. Graph the functions. So 0, 4, 1, 5, 2, 6, 3, 7, 4, 8. We just plot the coordinate points. Okay, we don't connect the points because the values between the given points have not been defined. Okay, discrete values. So we don't graph a line. A function whose graph is made up of unconnected points is called a discrete function. So this would be a discrete. Discrete points mean we only have specific points. Discrete. Example, graph the function 3x minus 1. Okay, so when x is equal to negative 1, 3 times minus 1 is negative 3 minus 1 gives you negative 4. So I have the coordinate point negative 1, negative 4. And then when x is 0, 3 times 0 is 0 minus 1 gives me negative 1. So I have the point 0 minus 1. And then when x is 1, I have 3 times 1 is 3 minus 1 is 2. So I have the coordinate point 1. Oops, the coordinate point 1 and 2. So again, we have the x and y, or x and f of x. Okay, ordered pair, x or f of x. And we graph it. So at negative 1, we're at negative 4. At 0, we're at negative 1. And at 1, we're at 2. And now we can graph the line because this is not a discrete function. Okay, every point is defined on that function. All right, so we can graph that. Connect the points with a line because the function is defined for all real numbers. Okay, so let's look at some more here. A carnival charges a $5 entrance fee and a $2 per ride. Write a function to represent the total cost. Okay, so the key here, $2 per ride. So the cost will depend on the number of rides. If you ride 1 ride, you will pay 5, the entrance fee, plus 2 times 1, that will be 7. If you ride 2 rides, you'll pay the $5 entrance fee, and 2 times 2 is 4, that would be 9. 3 rides, 5, plus 2 times 3. 2 times 3 is 6. That will be 11. Okay, so my function, the cost, and we'll use C to represent the cost, depends on, as a function of the number of rides. We'll use R for rides. And the equation then is $5 for the interest fee plus $2 for every ride. And that's what that says, $2 for every ride. So the cost depends on R, the number of rides. As I said, the cost, it depends on R. And for every ride you spend $2, but you have to pay $5 entrance fee. And then the Carnival charges a $5 entrance fee and a $2 per ride. Okay, so if you ride 12 rides, then you'll spend 29 bucks. $29. A local photo shop will develop and print the photos from a disposable camera for 27 cents per print. So the cost depends on the number of prints. Okay, per print. I would use P for print. The cost, C for cost, depends on the number of prints. And what we know is we spend 27 cents per print. So that would be 27 cents per print. Per print. Let's see here what they use. So they use f of x is equal to 0.27 times x. I use C and P. Okay. The cost depends on the number of prints. So that was the equation I came up with there. Although that would be acceptable as well. Okay, and let's see here. So if the number of prints is 24, then the total cost is going to be $6.48. $6.48. All right, so that's it. So lesson quiz. So you need to evaluate this function at 0, 1/2, and -2. And you also need to evaluate this function that they gave you at those same values. In lesson quiz part 3, a painter charges $200 plus 25 cents per can of paint. Write a function to represent the total charge for a certain number of cans of paint. And then B, what is the value of the function when the input for the number of cans of paints, and what does it represent? So, all right, so a painter charges $200 plus 25 cents per can of paint used. So when the number of cans of paint is 4, what do you get? All right, so that is 1.7. So we've gone over 3 sections, 1.1, 1.6, and 1.7 in a matter of 2 days. Okay, and if we were in school, if everyone in school, well, we would have probably spent, I would say, a total of 5 to 6 days on these 3 sections. But now we spend 2, so we move fast. Anyway, make sure if you understand and ask questions. Okay, I can join you in a Google Meet, so ask questions if you don't.